So, thank you very much, Keith. I'd like to take some time now to review what we said our goals were for GENI Spiral 5, to put those in perspective of the overall GENI program and to see how we're doing. I'll introduce that a little bit, and then we'll have 3 additional talks that go into somewhat more detail out of the GENI project office. When we complete those, we'll move on to the demos, which are more fun. But as Keith said, one of the nice things about the plenary is to be able to step back and see the progress that we've all been making together. And it really is extraordinary over this past year. So those of you who were at GEC at the beginning of the spiral, 2 GECs 8 months ago, will remember this slide and our key goals for Spiral 5. Rapid growth in GENI infrastructure, continue deploying more racks at more campuses involving more regional networks. Improve the experimenter experience to get a clean, consistent operating environment, and steadily increase the use of GENI in research, experiments, and in classrooms. How are we doing? Well, we're doing quite well. It's a very exciting time. We're making excellent progress meeting these goals. The nationwide deployment of GENI racks and GENI WiMAX sites is continuing. Heidi will talk about that in substantially more detail. You will see this morning a demonstration of stitching heterogeneous GENI assets across the GENI network. You'll see us stitch in non-GENI assets in a demonstration of the ways that GENI is expanding to enable other capabilities on campus and off campus. We've made a lot of progress integrating tool sets that cover more of the experiment lifecycle and make an experiment easier to run. And we'll have a very specific demonstration of that using GIME and LabWiki. We've been expanding GENI tutorials, training, and outreach. And doing all of these things is bringing good results. We're continuing to see rapid growth in experimenters participating in GENI, and we're seeing research impact in terms of international collaboration and influence, and in terms of published research papers. You know, we're watching the emergence of GENI as the nationwide programmable cloud owned and operated by experimenters. This is the emergence of a promise that we've all been working towards for quite a while. Let's look at GENI rack deployment. We have 2 GENI rack teams working directly through the GENI project, ExaGENI and InstaGENI. Each of these teams is working to a very challenging schedule, and each has delivered racks that are actively supporting both education and experiments. Most of you participated in one of the Getting Started with GENI tutorial sequences yesterday, and so most of you had the opportunity to use assets on these racks and have this experience. We are also continuing to work partnerships with spontaneous rack vendors. We have 2 actively engaged. Dell and Cisco are both building, for their own reasons, GENI-compatible racks. And this is a very nice validation of the overall concept. Now, we won't have a special presentation in the plenary on GENI WiMAX, so I want to do a small detour and cover some of the highlights of GENI WiMAX that, if you attended the GENI WiMAX session yesterday, you would have heard about. So the 2013 WiMAX deployment covers 13 GENI WiMAX sites with a total of 26 base stations. Currently, I believe 11 of these 13 sites are on the air, with 2 coming up in the sort of any day now timeframe. These are researcher-owned and operated 4G cellular systems supporting both local and remote experiments. And we've made a lot of progress in this past year standardizing not only the base station package, but the mobile experiment package, the client-side package, so that we can stand up full experiments using a standardized environment, controlling these experiments using OMF. So there's been tremendous progress here. And in a great convenience, we've managed to conclude a master license agreement so that we can operate our base stations in the EBS range without sort of fear of being spontaneously shut down. You also, if you didn't have the opportunity to attend the GENI WiMAX session, missed a very neat announcement. And Jim, are you here somewhere? Yeah, right here. So Jim Martin is the guy to talk to about this, but Clemson and Rutgers are leading an eager effort to build an MVNO, a mobile virtual network operator, to support research using the Sprint Artera wireless network. This is a experimenter. It's a network designed for experimenters. Jim is inviting GENI community members to participate. So if you have, now this is not, mind you, a venue for testing the Sprint network. We're not reaching in and conducting experiments on Sprint's infrastructure. But it is an opportunity if you have a wireless data-intensive experiment to work with a researcher support operator that probably can get you a very good deal on devices and on data. And Jim and this group are very eager to learn how to adjust the behavior of an MVNO so as to be most supportive to researchers. So if you have any interest, please talk to Jim at any time in the near future. This is not up today, but again, real soon now?
That's what we hope.
Excellent, excellent. So Jim's right back there. In the area of improving the experimenter environment, you saw yesterday in the Getting Started with GENI tutorial sequence, 2 different integrated tool sets. You will see the GIMI and LabWiki demonstration in a few moments. And these tools are really making a difference in making experimenters' lives easier. We get reports from experimenters that they are starting up much more quickly and are getting to the point of conducting their experiments rather than sort of fussing around with GENI stuff in a much more rapid fashion. One example that we've seen emerge really just in this past year is the GENI portal. So we had a lot of concern from both new and even relatively experienced GENI experimenters that they were simply spending too much time getting to experiment startup. They were handling too much cryptographic material, too many certificates, too many keys. Now these things are essential for GENI security and they're not going away, but that doesn't mean the experimenter has to touch them, him or herself. And so the solution that we came to as a community was to create a simplified point of entry for experimenters, the GENI portal. We tied that in with the InCommon Identity Provider Federation in order to make onboarding easier. So many of our experimenters already have InCommon identities, already have identity providers through the InCommon Federation. And as a result, we've seen just in 8 months of operation, over 500 accounts created, and we're getting very strong positive feedback from both experimenters and educators. Most of you had an experience with the GENI portal during the tutorials yesterday. Experimenter support and outreach, we're doing a lot more work in tutorials, both at GECs and in non-GENI venues. Vic will talk about this in some detail. We're seeing dramatically expanded use of GENI in the classroom at undergraduate and graduate levels, both in project work and in regular curriculum efforts. And we've continued the ongoing effort of GENI camps and experimenter workshops. In fact, we just wrapped up our second annual GENI summer camp this June. We had 17 campers from across the US. Some of you may recognize yourselves here because Among the projects that were completed, 2 actually came back and ran demos at last night's demo night. So what's the punchline here? The punchline is that the hard work that all the people in this room have been doing is really helping. GENI's growing. We will exceed 50 campuses in the current deployment phase, and we're starting to see a real movement of spontaneous GENI racks, both commercial developments and campuses choosing to deploy their own GENI racks outside the efforts of the GENI program. We're also seeing the same in our sister program, US Ignite. Experimenter uptake is growing quickly, a growing user community, strong classroom participation, and the research impact is impressive. Growing body of academic literature and a great international collaboration effort. Vic will show you some more pictures of experimenter growth, but if you look at the bottom graph, you will see that we are flirting with the 1,000 unique experimenter milestone, which, you know, it's just a number, but it's a number that we're pretty proud of. We've cataloged over 100 relevant papers for GENI. Of course, we can't catalog the ones we don't know about, so we would love to hear from you if you are publishing GENI relevant work, either work that goes to the development of GENI or work that uses GENI to conduct your research. Please just send us an email. We'll get your papers in the bibliography. And we're partnering with peer projects worldwide. And on a basis of equality, we are sharing our resources with our partner projects. They are sharing resources with us. We are building, more exciting experiments as a side effect, and we are sharing the technology that enables these test beds so that we can make more interoperable systems. It was a very exciting time for GENI, and thank you all for building it. Marshall.
Good morning, everyone. I'd like to drill down a little bit on Mark's remarks in the area of architecture and talk about recent progress and sort of where we're at right now and where the vector is heading in terms of certain dimensions of architecture. So the GENI architecture has made a lot of strides in the last year, particularly in a number of dimensions. There are more resources. There are more experimenter-focused services and tools, and more federation-focused services and tools, and I'll talk about what I mean by that in a second. And there's more integration among those services and tools, so that whereas I think a year or maybe two years ago, there was a lot of capabilities, but they were all sort of piece parts. There's a lot of things that are sort of telling a more integrated story. So I want to sort of take a few minutes and review sort of where we've come, where we're going. And I want to lay this down on top of, many of you have seen this diagram. This is Gene Oren put together this story of what is the life cycle of the experimenter? GENI wants to support this whole story. We want to allow you, the experimenter, to get your resources, design your experiment, make sure that you're doing things in a trustworthy, accountable environment, get your resources, put your experiment, run your experiment, gather your data, analyze it, tear down the experiment. There's a whole life cycle here. And I'd like to be able to sort of show you, the goal of the program, roughly speaking, is to make sure that this whole life cycle is fleshed out, that there's a good way to do all these things, hopefully as integrated as possible. So I'd like to sort of show us, fill this in. This set of graphics I'm going to show is not intended to be entirely comprehensive, but it's to sort of give you the idea, so I apologize if I've left out your favorite piece of GENI. But this is GENI as of early 2002, or what we consider more natural units, GEC17. At the time, There was a lot that was there. There was certainly a lot of GENI you could do. You could do experiments. We had slice authorities. We had the AIM API. We had some tools. We had a number of resources. We had the mesoscale was fully there. We had WiMAX, though a lot of these things were not integrated, but they were out there and they existed. And the GEMINI and GIMI projects had some tools that were being developed for the support of experiments. So it's not, and just going down the bottom, the AIM API, just to finish off the circle, the AIM API not only deals with creating the resources, but cleaning things up. So it's not that we had nothing there, but you'll notice that a lot of things that we take for granted right now, things that we consider to be sort of core, essential, take for granted parts of GENI just weren't here at all. This is kind of where we're at right now, adding on to that. So the gray was last time, the light blue, if you can see the difference in colors, it looks much brighter here. As of now, we have, I'm just going to highlight a few things. We have the Meta Operations Center. We've got the GPO clearinghouse. We've got an additional layers of the AIM API. We've got the racks, which just there were no racks a year and a half ago. We've got the GENI portal. We've got the ability now to put in post-boot scripts and the management of user accounts and SSH, so that people can sort of log in a uniform fashion. The GENI, the GEMINI and GIMI tools have evolved into two very impressive end-to-end capabilities, the GENI desktop and the GIMI portal, one of which you're going to see a demonstration of in a few minutes, which are integrated not only among the tools within those capabilities, but within the tools that have come, that we're building on top of. And we've got a story that's developing about being able to archive the data that are coming from these experiments. So as you can see, we've done a lot to fill in this story. And I think our plans can be couched, our plans for the rest of this spiral can be couched in terms of filling in this even more. And that's more resources. We're going to be talking more about stitching in the next few presentations. We're going to be adding in stitching capability, making it available for experimenters, integrating WiMAX into the rest of the GENI resources, working towards a uniform experimenter environment, enhancing the experiments, the support that we give to experimenters, lots more resources, the more integrated. I want to Mark talked a little bit about the portal and the clearinghouse. I just want to give a little bit of a detailed case on recent progress. Starting at about early 2012, the GENI architecture team, we started talking about a clearinghouse architecture, trying to make sure that there were standard sets of services so that the Federation could have a standard, trustable approach towards authentication and authorization and accountability. And so we built this design and started to work at it. We ratified the design together as a community, and we decided to build the clearinghouse and then a tool, an experimenter-friendly tool to make it easy to do relatively easy things, sort of an easy on-ramp for GENI to get, for GENI users to get resources. By GEC17, we demonstrated a prototype of the clearinghouse and the portal. By last GEC, it was sort of open for business, and people were starting to use it. And by now, I think it's safe to say that it is certainly a public face of GENI and the standard interface for many of the demonstrations and tutorials. Many of you have seen this. Mark showed a picture of this. This is something I'm particularly want to focus on. This is portal users. We were starting from, obviously, nothing in the beginning. And the blue is the total number of registered users within the clearinghouse that have been using the portal. The red represents those that have come in using their in-common identities. So you can see that at the beginning, there were a lot of people that were using in-common, and just as many people were coming in using the GPO, that we were sort of creating our own. But that, the growth of the in-common, the number of people with in-common has been fairly steady all the way through, whereas the number that have not used in-common, and we've had to create our own identity here at the GPO at our IDP, has nearly leveled off. And I think that's a sign of the success of the in-common, of this in-common federation, but also there's community pressure to go back to universities, members of the in-common federation, and cause them to release the right credentials so that their university can have that single sign-on mechanism that's so attractive. So this is a very nice result, and we're expecting, we like the slope of the curve. We like the fact that there's this divergence between the GPO line and the in common line. We expect to see this to continue to grow. So in summary, the architectural goals of GENI have always been sort of twofold and down to two different directions. We want to provide experimenters with custom, deeply programmable topologies from a variety of rich, diverse resources. At the same time, we want to provide federation members, the owners of those resources, with a sense of trust based on authentication, authorization, and accountability. And I think we've made significant progress along both of these dimensions. And our current plans are to continue to address these goals. We've added lots of resources recently, and there are plenty more that are coming. We've added a lot of tools and services for running experiments, getting resources in custom topologies and running experiments on them in a federated, authenticated, authorized, accountable fashion. And we as a community are transitioning from sets of individual tools that are out there that have to be sort of handcrafted and put together by the experimenter into integrated capabilities. And I think we as a community are also transitioning from building individual tools to identifying capabilities that enable tool builders to make it easier to put together capabilities. Okay, thanks very much.
Is this your adapter? Mine. I just don't want anyone to lose their adapter.
Thank you.
Yeah, it still works. Okay. I'm going to give an update on the infrastructure and operations before we can do all the experiment cycle that Marshall just showed. We have to make sure that there are resources out there to do it, and GENI does that through a combination of collecting and collaborating on resources that come from all of you, and deploying certain kinds of resources like GENI racks, which are supported directly through some of our past solicitations. So this is my slide that I always show, the location of all the infrastructure racks and campuses. We still have some that are unfunded. And we're, so we're continuing to work on everything that's green there, and we're continuing to look for ways to make some of the yellows turn to green. There's 43 racks that are covered under the original plan of what we were deploying, and as Mark mentioned, there are more racks that are arising from either campuses who are installing their own equipment or vendors who are getting interested in the GENI rack design and working on trying those out in prototype and also on campuses. And so we have a deployment plan that we're working through that goes to February of next year. In addition to that, we are working with a lot of campuses who are either expanding the open flow networks that they already have or putting new open flow networks onto their campuses. On every GENI rack, there's an open flow port, and that port connects to your campus LANs. And from there, you can attach any sorts of resources that you think make sense to either experiment with GENI or be part of open flow experiments or be part of US Ignite. So that's part of the expansion as well. All of the racks continue to get software updates, and the software continues to get tested both in site acceptance testing and in conformance testing to make sure that the API and the open flow all works in an interoperable way between anybody who's a GENI site. You can see the status of the two rack teams. The InstaGENI and ExoGENI teams do an incredible amount of work with a very small and very talented staff. They paid me to say that. But really, they should get a huge amount of credit for the progress that we've been able to make with getting racks out of there. This is a list for all of those of you who don't have racks yet and are interested in it. If you haven't already been contacted or you haven't already seen your campus on a list that I've put up in previous sessions, these are the things that you have to provide as a campus or a business or possibly a regional network in order to operate a GENI rack successfully. It's pretty simple, space, power, and air conditioning, security for the rack. 1 gigabit, for some campuses, finding 1 gigabit research networking has been an issue. But for most campuses, it's been okay. And most of the people in this room have research networking connections that are perfectly capable of doing that. It's fine if it's shared with other research programs. It doesn't have to be just dedicated to GENI. But it doesn't want to be on the same network that you're running your, backups of all of your production systems in your university, obviously. You have to commit to continue operating with up-to-date versions of GENI software. So eventually the rate of changes in the software will slow down, but right now you're contacted directly either by the rack team or by the GPO when software needs to be updated. And you can pretty much count on that being a quarterly or monthly affair at the moment. Depending on which features and which kinds of things you're doing at your campuses. You need to allow other people in GENI to use your rack because that's what this is based on, so people can get VMs and get data connectivity to your rack. And you need to have at least 1 or 2 individuals who will be points of contact for responding to issues. This is an update of where we are with our rack deployments. We've got 22 racks that are either installed or in progress, so we're about halfway towards our goal. And we also have, in the collaborative project with Cisco, the WVNet regional network has been working with the GENI team to develop and integrate a GENI rack in that location and make it available to their members. And at Clemson, the Dell rack has a similar project going on, and we've been involved with both of them as far as trying to make sure things are interoperable and support them with testing and advice about the new versions of software. So we continue to work with everybody once they get their rack to do testing and integration and bring up each site. So if you're interested in whether a site is actually up or down as far as has it been tested, has it gotten its hardware, has it made it through confirmation testing, these are the URLs to click on. We like to get everybody to send us a picture when they when they install their rack. The one on the bottom is the super rack at Utah now. So it's an InstaGenie rack with lots of extra processors in it. It doesn't go all the way to the back of the picture, but it looks nice. We're excited about that one. It's in the middle of coming up. The GEC interrupted the progress there. And if you want details about the networks and how a campus connects or how a regional connects, there's the URL to go to for that as well. So I'd like to thank all the campuses who have been working with us for being tolerant of being deployers without a whole lot of documentation, and to being guinea pigs for a couple of places have decided that they need to completely take apart their racks because they have data center specifications that don't exactly match what the GENI rack required, which was an unexpected thing to us. But luckily, both of them said, yeah, we want it, we're willing to do that work. And our rack teams said, yeah, we want it, we're willing to try and put it back together after they take it apart. So we appreciate everybody's patience, and we're continuing to make progress there. On the OpenFlow side, most of you have seen this before. This is the same way that we're connecting through the mesoscale, using shared VLANs for many experiments or dedicated VLANs if people need them. And we've been focusing a lot on getting more sites up and integrated, but there will be some information on how the OpenFlow releases have changed in the operations sessions, and there's a little bit at the end of this too. So GENI and InstaGenie both connect, and now they can talk to each other. We have quite a number of regionals already involved. This is with the number of racks that were in process of deployment, and actually we have not shown things like WVNet here, which we expect to be up soon, but since it's still in the process of becoming a GENI rack, it's not on this chart. But that's been an important thing for GENI, because the regionals really give us a chance to offer different ways of connecting, especially between projects that are GENI and non-GENI. So we really appreciate their support too. And you'll see it in the stitching. In the core networks, the NLR OpenFlow expansion is in progress. We're still working on that one. Hopefully at the next GEC we'll have some results to show and more topology options from that. In Internet 2, the cross connects to AL2S are available for campuses or projects that need to go in between the new AL2S or the high-speed Internet 2 dynamic circuit service and GENI. The Science DMZ design that Internet 2 has been working on with many of your campuses has a GENI rack now integrated in with it, and we're going to try that at our first campus real soon now. So we think that'll all work, but if you're not that campus, then you won't be the guinea pig. And condolences to the one that is, probably Clemson. We're expecting the GENI aggregate manager from Internet 2 for the AL2S network, and if you saw the demo night last night and saw Internet 2's demo, they're making good progress on that, and we're able to show GENI RSpecs being used to make connections in a model of what was going to happen there, so that's encouraging. And then finally, the ion stitching aggregate that we're going to show will be demonstrated and is working in Internet 2, and we have a commitment from NLR that they also want to participate in GENI stitching later. Right now they're focusing on their OpenFlow deployment, but they're committed to that as well. So the next two slides are summaries of the current versions of software and firmware that we're using in the OpenFlow network. Some of these are the same as last time, but we have gotten, in particular from IBM, new versions as part of the ExoGENI deployment. So that's been exciting and successful to see how we can do that with a combination of shipping and deployed racks. The FlowVisor software has advanced quite a bit and added new features, and there's more information on that on the FlowVisor wiki, and also Josh has been in contact with FlowVisor sites. If you're interested in SDN, you should seek him out, and he can give you all the inside story about what to do for that. We've done quite a bit of work on the monitoring side to add some new features. If you come to the operations session this afternoon, not as an official GMOC software, but as a demonstration of measurement software that we hope will be adopted and be able to report more on statistics as opposed to just OpenFlow status. We'll have a prototype demonstration of that from Chaos Golubitzky. So the dark and ominous looking screen is a shot that I stole from Chaos's talk. But it's actually bright and happy monitoring. So this is showing statistics about different data paths from a single aggregate. And I know you can't see it here, but you'll be able to see it in her talk and zoom in and see more about what it's about. This is actually counting the messages back and forth to FlowVisor. So it's realizing a long-term dream that we had of being able to do more measurements with our deployed OpenFlow infrastructure. And then, of course, the operations people have continued to be busy. The GMOC has been supporting our rack deployment. They've also been working on revisions for the emergency stop procedure. We all continue to support through IRC chat and tickets and all the same mechanisms as before, but we're expanding basically the amount of GENI stuff that covers. So thanks very much to Indiana University for doing that. that's it.
Good morning. I'm Vic Thomas from the GENI project office, and I will be giving you an update on experimenter support related activities at the GPO. So I'll start by showing you the graphs you've all been looking for. How fast are we growing in terms of numbers of users and the numbers of resources being used? Well, the graph, I guess this is how fast, really fast. The graphs on top show the numbers of users and slivers created on the GENI racks, and the numbers at the numbers at the bottom show the numbers of users and slivers created on the GENI resources. If you look, you'll see that the lower lines there show the numbers of slivers created on the racks. So since the racks are new, but they start off low, but there is a rapid growth in the numbers of slivers being created there. The GENI racks are also relatively new, but there has been a tremendous growth in their usage since the last GEC. So as Mark said, we have over 1,000 experimenters who have created over 23,000 slivers on these resources. In terms of publications, there are over 100 publications that are related to GENI. These are listed in the bibliography section of the GENI, of the experimenter page on the GENI wiki. And if you have any publications that should be listed there, please do let us know, and we will add it to the list. So if you go to the experimenter page on the GENI wiki, there's a little button for Cite where you will see where you can see a list of these publications. So in terms of what the experimenter support group does, we have two main priorities. The first is to grow the number of experimenters using GENI, and the second is to support existing experimenters. Obviously, these two are very closely related. If we don't do a good job of supporting existing experimenters, we will lose them and will not be able to grow experimenters. If we do well in our support, more people hear about GENI and how useful it is, and we will grow the numbers of experimenters. So they are related. Some of the kinds of things we do in these areas are direct support of experimenters, answering emails, responding to IRC, hanging out in IRC channels and helping people, increasing the classroom use of GENI, better documentation, advocacy, where we work with the software groups, GENI developers, represent to them the needs of the GENI experimenters, conduct tutorials, summer camps, do invited talks, and provide helper scripts and programs to make it easy to use GENI. Quickly, things we do in each of these areas. Invited talks, like to highlight some of the recent ones since the last GEC talks at UC Davis and UC Berkeley. And tutorials and summer camps, updates since the last GEC. We had a full-day tutorial at ICDCS, which went really well, based on the feedback from the attendees. There was also a summer camp that happened last month. I'll have a few slides about that at the end. In terms of classroom use, would like to highlight Violet from Arizona State University. She was here at the last GEC. It was her first GEC. She was really excited by what she saw here, went back and used GENI in her classroom. The very next week, she had 2 exercises based on GENI, including an open flow exercise. There's a Birds of a Feather dinner tonight for those interested in using GENI in the classroom. So if you're interested in joining us, please email me, and I will send you details. In terms of direct experimenter support, we have mailing lists, which are very actively used, IRC channels, and I believe we have done really well here in terms of direct support being responsive. We've gotten acknowledgments such as this in the thesis, in fact, Nikki likes to point out that she's been cited more often in the acknowledgement section of thesis and defense and dissertations than in the actual research. But in terms of documentation, we have a newcomers page on the GENI wiki and a new page that describes key concepts. The pages we had were out of date. They've been updated and are hopefully easier to use. So if you go to the GENI wiki, go to the newcomers page and follow the link to GENIConference, you'll find this there. One of the things we have spent quite a bit of time on is helper scripts and programs that make it easy for experimenters to use GENI, automate some of the routine tasks or error-prone tasks. Examples are OmniConfigure, which automatically generates a Omni configuration file based on information about you in the portal. Eliminates many of the common errors involved with creating this config file. Ready to log in is another useful script that monitors the status of your resources when they're ready to use. It tells you exactly, it extracts from the manifest for the resource the information you need to log in and gives you the command you need to type to log into those resources. Dingbot, which was described yesterday, one of the sessions helps you write post-boot scripts that are fairly resource and OS independent. And then there's the GENI portal that Mark talked about that has made it extremely easy for tools to access experimenter certs and keys. So it used to be that every tool you used, you had to point it to your certs and keys. Now you can get to these tools from the portal, and the tools have access to your certs and keys, and so you don't have to set up configuration files or tell the tool how to find this information. Every tool had a different way of doing this. So all these things have we believe, helped make it easier for the experimenter. In terms of advocacy, as I mentioned, we work with the software groups and other just GENI developers, tool developers, and represent to them the needs of the experimenters. Examples of things we have done are slice membership, where you can have multiple users as members of a slice. This is especially useful if you're using GENI in the classroom. You can have the student who's the owner of the slice, but you can also have the instructor or TAs as members of the slice, so they can help students debug, for example, the experiment running on a slice. The other examples are shared interfaces on GENI, so if you on a Proto-GENI nodes. So if you need more than the 3 interfaces you need, you can have shared interfaces. And we also, when we hear of bug reports, we try to reproduce these bugs and work with the developers on getting them fixed. In terms of just our strategy for experimenter support, we would like to spend more time supporting advanced GENI experimenters, such as FIA teams, domain science. And our strategy for doing this has been just better tools and documentation, which has greatly reduced the amount of time we spend answering the same questions again and again and again. So for example, OmniConfigure has reduced the number of from yes, from 2 to 3. So what happens if you, so we used to get 2 to 3 questions a week on just OmniConfigure, and it's down to close to 0. And likewise for the using of the portal and passing credentials to tools, we get almost no questions about that. So we've been able to reduce the time answering the same questions again and again, and spend more time supporting advanced experimenters. In terms of training, we would like to do even more training of experimenters, have more tutorials. And the way we'd like to do that, and the way we have been doing that, is having more packaged tutorials that community members can take and do their own tutorials at different venues. So the good examples are the introductory GENI tutorial based on the portal and the introductory OpenFlow tutorials. They have been very successfully used by Violet at Arizona State and Debbie at Indiana University. So we'd like to do more of that and see more of you do tutorials and at various conferences and other venues. I mentioned the summer camp. It happened last month. Bing from the University of Connecticut was organized the summer camp with along with Kaiki and Yin and Yong. It was at the University of Connecticut, and the theme of this summer camp was wireless, so WiMAX, just wireless resources in GENI. There were 7 tutorials that covered a variety of GENI tools and the GENI experiment lifecycle. There were 17 attendees, including 1 undergraduate and 1 faculty member. And this attendees had to do projects, in group projects. There were 5 projects, and they all did live demos. One of the big differences between this summer camp and the last one was that the attendees spent very little time having to actually deal with GENI issues. So they got to spend a lot more time working on their research experiments. And they made a great deal of progress, were able to do live demos. And in fact, 2 of the summer camp teams had demos yesterday at this GEC, which is quite impressive considering the summer camp was about 3 weeks ago. Another new thing at the summer camp was all these teams used the Gemini and GIME instrumentation systems to actually see how the experiments ran. So next GEC at Iowa, so please join us there. Next summer camp at Iowa. We hope the ice cream there is just as good as the ice cream in Connecticut. So hope to see you there. And that's it.